1. Introduction: the paradigm shift to localized intelligence. The computational landscape of artificial intelligence, AI, is undergoing a significant bifurcation. While hyperscalers continue to train trillion-parameter models in massive data centers, a concurrent revolution is occurring at the edge. The capability to run high-fidelity large language models, LLMs, on consumer-grade hardware has transitioned from a theoretical possibility to a practical reality, driven by advances in quantization techniques and efficient inference runtimes. This report details the architectural design and implementation of a robust, self-hosted AI platform that mirrors the functionality of commercial APIs while retaining absolute data sovereignty. The objective of this infrastructure is to provide a unified, internet-accessible interface for local LLMs. This system must serve two distinct consumer types: human users interacting via a rich chat interface, Open Web UI, and programmatic clients consuming an OpenAI-compatible API, LM Studio. To achieve this while mitigating the severe security risks associated with exposing local hardware to the public internet, we employ a zero-trust networking architecture. This report serves as a definitive implementation guide for DevOps engineers and system architects. It integrates LM Studio as the high-performance inference engine, Docker for containerized application management, Tailscale for secure, NAT traversing networking, and Caddy as an intelligent reverse proxy and security gateway. By the conclusion of this document, the reader will possess a production-ready blueprint for a personal AI cloud that is secure, scalable, and accessible from anywhere in the world. 1. Architectural overview. The proposed stack is composed of 4 distinct layers, each selected for its specific strengths in the modern DevOps ecosystem: layer component role key, justification, network, overlay tailscale mesh, VPN, and ingress. Eliminates the need for dangerous router port forwarding. Provides funnel capabilities for public ingress. Manages TLS certificates via Magic DNS. One security gateway, Caddy reverse proxy native integration with Tailscale for automatic HTTPS. Simplifies complex routing logic, API versus UI, enforces authentication barriers. 3 inference runtime, LM Studio models server superior, support for GGUF quantization. Robust headless CLI operation. Creates an OpenAI-compliant API endpoint for universal compatibility. 5 presentation Open Web UI chat interface, a feature-rich, containerized UI that mimics commercial chat experiences. Supports RAG, retrieval augmented generation, and multi-model management. 7. The interaction model is designed to minimize latency while maximizing security. External requests originating from the public internet are encrypted and routed via Tailscale's relay servers directly to the local host. Caddy intercepts these requests, terminating the TLS connection. Based on the request path, Caddy routes traffic either to the Docker container hosting Open Web UI or directly to the LM Studio API port, enforcing basic authentication for the latter to prevent unauthorized API consumption. 1. 2. Hardware requirements and capacity planning. Before deploying the software stack, one must validate the underlying hardware. Self-hosting LLMs is memory-bound rather than compute-bound for single-user scenarios. VRAM considerations. The primary constraint is Video Random Access Memory, VRAM. The model weights must fit entirely within VRAM to achieve acceptable token generation speeds, tokens per second, or TOK-S. 7B, 8B parameter models, ETG, Llama 3, Mistral, require approximately 6 to 8 GB of VRAM at 4-bit quantization, Q4KM. 14B, 20B parameter models require 12 to 16 GB VRAM. 70B parameter models require 24 GB plus, often necessitating dual GPUs like RTX 3090 or 4090. System memory, RAM. While GPU offloading is preferred, LM Studio can offload layers to the system's CPU and RAM if VRAM is exhausted. However, this incurs a significant performance penalty, often dropping speeds from 50 plus TOC-S to 5 TOC-S. A minimum of 32 GB system RAM is recommended to support the operating system, Docker containers, and partial model offloading. 92. Infrastructure foundation, operating system, and networking. This section establishes the bedrock of our deployment. While LM Studio and Docker are cross-platform, Linux, specifically Ubuntu LTS, is the recommended host operating system for this architecture due to its superior handling of container networking and background service management. 102. 1. Host environment preparation NVIDIA driver. Installation. For LM Studio to utilize the GPU, the proprietary NVIDIA drivers must be installed. On a fresh Ubuntu installation, bash sudo apt update and sudo apt upgrade. Sudo apt install, Ubuntu drivers common sudo, Ubuntu drivers, auto-install verify the installation with NVIDIA SMI. The output must show the driver version and CUDA version. Crucially, the CUDA version displayed here is the maximum supported version. LM Studio includes its own bundled CUDA runtime libraries, but they rely on the host driver being present and compatible. 2. Docker Engine and Compose Open Web UI is distributed as a Docker image. Using Docker ensures that the complex Python dependencies and front-end frameworks required by the UI do not interfere with the host system. Installation strategy: do not use the Docker I/O package from standard repositories, as it is often outdated. Install from the official Docker repository to ensure support for the latest Compose features. Bash MOS, set up Docker's apt repository. Add Docker's official GPG key, sudo apt-get update, sudo apt-get install, key certificates curl sudo install, m0755d, etc. apt keyrings, sudo curl, fssl, https, download. Docker, com, Linux, Ubuntu, GPG, o, etc. apt keyrings, .docker, sc sudo chamod a plasma, etc. apt keyrings, or docker, asce, add the repository to apt sources, echo hadarj, deb, archcharts dpkg, print architecture, signed by, etc. apt keyrings, .docker, as, https, download. Docker, com, Linux, Ubuntu, shaz-dar, etc. os release, and an echo, version codename, stable, ni sudo t, etc. apt sources, list, d docker, list, dev null sudo apt get update, install Docker packages, sudo apt get, install Docker CE CLI containered, IO Docker buildx plugin, Docker Compose plugin user permissions. To avoid running Docker commands as root, which can mess up file permissions for persistent volumes, add the current user to the Docker group, bash sudo usermod, ag docker, user new grp docker 2. 3. Tailscale network. Layer Tailscale creates a secure mesh network, Tailnet, that overlays the public internet. It allows devices to communicate as if they were on the same physical LAN, regardless of their actual location. Why Tailscale? Traditional remote access requires opening ports, port forwarding, on the home router. This exposes the device to port scanners and botnets. Tailscale uses NAT traversal techniques, stun, turn, to punch through firewalls securely, establishing encrypted WireGuard tunnels. 1 installation, bash curl, fssl, https, tailscale.com, install, sh, sudo tailscale. Upon running tailscale up, a URL is generated. Visit this URL to authenticate the machine and add it to your tailnet. DNS configuration, Magic DNS. To use SSL certificates effectively, Magic DNS must be enabled in the Tailscale admin console. This assigns a stable host name, e.g., GPU server, tailnet name, tsnet, to the machine, which is resolvable from anywhere inside the tailnet. 113. The inference runtime. Deep dive into LM. LM Studio has evolved from a simple GUI application into a robust server platform capable of headless operation via its command line interface, CLI, LMS. This section details the configuration of the inference engine. 53.1 installation and the LMS CLI. While LM Studio offers an app image for Linux, the CLI workflow is preferred for server deployments. The CLI tool LMS allows for scripting, automation, and service management. Bootstrapping the CLI. If you have the GUI installed, the CLI might already be available or can be bootstrapped. For a purely headless server, use the installer script bash curl fssl https lm studio ai install sh bash. After installation, verify the binary is in your path. Bash LLMs help. The output should list subcommands like server, ls, load, and get. 133.2 Model management, selection, and quantization. The effectiveness of the entire stack depends on the model loaded. LM Studio natively supports the GGUF format, which is optimized for running on CPUs and consumer GPUs via Apple Metal or CUDA. Searching and downloading. Use the LMS get command to query the Hugging Face hub. Bash LLMs get Llama 3 8b instruct. The interface will present a list of available quantization levels. Q8.0. Highest accuracy, largest size, near float 16 performance. Q4.km. The sweet spot for most users. Balance perplexity, accuracy, and size. Q2K. Significant degradation in reasoning capabilities. Not recommended unless hardware is severely constrained. Listing local models. Once downloaded, models reside in the internal cache. To see available models and, crucially, their model key or path, bash LLMs ls. This command returns the identifier required to load the model programmatically. 133.3 Server architecture and configuration. The LMS server command spins up a local HTTP server that mimics the OpenAI API specification. This compatibility is vital as it allows tools designed for OpenAI, like OpenWebUI, to plug into LM Studio seamlessly. The binding address, host, by default, LMS server, start binds to 127.0.0.1, localhost. 5. Implication, only processes on the same physical machine can access it. Docker, nuance. A Docker container on a Linux host cannot easily reach 127.0.0.1 of the host without specific networking flags. Host, Docker, internal. Security. We want to bind to localhost. We do not want this port, 1234, exposed to the LAN or internet directly. Caddy, our proxy, will handle the ingress. CORS, cross-origin resource sharing. Web-based interfaces, like OpenWebUI running in a browser, often strictly enforce CORS. Even though OpenWebUI runs server-side, enabling CORS on LM Studio is a best practice to prevent connection rejections during complex fetch operations or client-side plugin interactions. 14. Command construction. The robust command to start the server manually is bash LLMs server start, port 1234, cause. However, this is a foreground process. For a production report, we must configure this as a background daemon. 3.4. Persistence. System service implementation. Relying on a terminal window to keep the server running is fragile. We must create a system service to manage the LM Studio process, ensuring it starts on boot and restarts on failure. 10. Service file creation. Create a file at issue system LM Studio. Service. INI TOML unit. Description LM Studio inference server. After network online. Target wants use network online. Target type such as simple user. Your username. Set the home directory to ensure LMS finds the model cache. Environment. Home. Your username. Working directory. Your home. Your username. Pre-start command to ensure a specific model is loaded into memory. This uses the load subcommand to prep the GPU before the server listens. GPU max, Offload all layers to GPU, context length, set to 8192, or model max 0. Identifier sets the API name, e.g. your local model, exec start pre, USR, local bin, LMS load. GPU max, context length, 8192. Identifier, local LLM main process, the HTTP server exec start, USR, local bin, LMS server start, port 1234, core start, restart, logic restart, always restart, sec10 install, wanted by multi-user. Target key configuration, details, exec start pre. This is critical. The server itself is just a listener. If no model is loaded, API calls will fail or trigger a lazy load, which causes latency. Preloading ensures readiness. 9. Identify a local LLM. This abstracts the complex GGUF file name, e.g. llama38b instruct v2q4km giguf, into a simple string local LLM. API clients will request this clean name. 9. User must be your non-root user who downloaded the models, as models are stored in Maah Cache LM Studio. Enabling the service, bash sudo system ctl daemon reload, sudo system ctl, enable LM Studio sudo system ctl, start LM Studio check status with system ctl status LM Studio to ensure the model loaded successfully and the port is listening. 104. The presentation layer, Open Web UI via Docker Open. Web UI, formerly Llama Web UI, provides a polished, ChatGPT-like interface. It supports chat history, user accounts, RAG, document upload, and web search. 4. 1. Docker networking strategy. Critical challenge in containerizing Open Web UI on Linux is establishing connectivity to the LM Studio service running on the host. The issue: on Linux, Docker containers do not resolve host. Docker, internal by default. 16. The fix: we must inject this mapping using the extra host directive in Docker Compose. This maps the internal host name to the special host gateway IP, usually 172. 17. 0. 1. Allowing the container to route traffic to the host's localhost ports. 4. 2. Docker Compose configuration, create a directory for the project, bash mcdir, AI stack cd, AI stack touch Docker Compose, YML Docker Compose, YML content, YAML version. 3. 8 services, OpenWebY, image, GHCR, IO, OpenWebY, main container name, OpenWebY, restart, always ports. 3000, 8082, our expose container, port 8080 to host port. 3000 environment, our connection to LM Studio. We use the v1 suffix because LM Studio is OpenAI compatible. OpenAI API base, URL, HTTP, JOT host, Docker, internal, 1234, v1, out, API key, LM. Studio doesn't strictly enforce it locally, but the client requires a value. OpenAI API key, LM Studio. Security settings, Web UI, auth true. Enable login screen, enable sign up true. Enable for initial setup, set to false later for security. UI customization. Default models, local LLM. Matches the identifier set in LM Studio service volumes. Open Web UI data, Art app, backend, data. Critical, enable host resolution on Linux extra hosts. Host, Docker, internal, host gateway volumes. Open Web UI data, environment. Variable analysis, OpenAI API base. URL. This defines the upstream backend. Since we are using the generic OpenAI driver in Open Web UI, we point it to the LM Studio API. 8. Web UI auth ensures that the UI itself is password protected. This is distinct from the basic auth we will add to the API later. This protects the chat history and administrative settings. 18. Default models pre-selects the model we loaded via the LMS load command. 194. 3. Deployment and verification. Launch the container. Bash Docker Compose up. Demonitor the logs to ensure it connects to the database and initializes. Bash Docker Compose logs. Fonts running. Navigate to HTTP. Localhost $3,000 in a local browser. Create the first admin account. Go to Settings Connections and verify that the connection to http://host Docker Internal 234 v1 is verified. Green checkmark. If it fails, check the extra host's configuration and ensure the LM Studio service is active. 205. The Zero Trust Gateway, Tailscale Funnel, and Caveat. This stage, we have a working local stack. Open Web UI on port 3000. Talk to LM Studio on port 1234. Now, we must expose this securely to the internet. 5. One Tailscale Funnel versus Serve Tailscale offers two exposure modes. Serve exposes a service only to other devices inside the tailnet. Private mesh. This is the most secure method, but requires the client device, e.g., a phone, to have the Tailscale app installed and active. 212. Funnel exposes a service to the public internet. Tailscale accepts traffic on a public relay server and tunnels it to your machine. The user request specifies accessible over the internet, which implies funnel. However, exposing internal ports directly to the public web is risky. Therefore, we will use Caddy as an intermediary to secure the traffic. Enabling funnel. Go to the Tailscale admin console, access controls. 2. Ensure the funnel attribute is allowed for your user node. 3. On the host machine, configure funnel to route public port 443 traffic to local port 443, where Caddy will listen. Bash sudo tailscale funnel 443 on this command reserves the HTTPS net domain for this machine and routes traffic to it. 25. 2. Caddy. The reverse proxy. Manager Caddy is chosen over Nginx because of its automatic TLS integration. Caddy can interface directly with the Tailscale socket to provision certificates for TSNet domains automatically. For installation, on host, install Caddy using the official deb packages as detailed in section 2. 3. Do not run Caddy in Docker unless necessary, as mounting the Tailscale socket into Docker introduces permission complexities. 22. Running it on the host is cleaner for this specific architecture. 5. 3. Designing the Caddy file. The Caddy file is the configuration map. It needs to handle two scenarios. Scenario A, browser chat. The user visits the root URL. Caddy forwards to Open Web UI. Open Web UI handles its own authentication. 2. Scenario B, API call. A script requests a v1 chat completions. Caddy forwards to LM Studio. Since LM Studio has no auth, Caddy must enforce basic authentication here. Generating passwords. Bash Caddy hash password. Plaintext my secret API password. Output to a $14. Hash string. The configuration, etc. Caddy and Caddy file. Code snippet. Define the Tailscale domain. Caddy detects the TSNet suffix, na, and attempts to fetch the cert from the local Tailscale daemon. Machine name, Tailnet name, TSNet, no one, API protection block, yard, match, any request starting with v1, OpenAI standard path, handle path, v1, Yahoo security, require, username, password for API access, basic auth, Yahoo format, API user to a $14, XLI W6V LHR5NFOFU 0Z2GTNMPKT 5QR7H4 IJWJPDHJVG shows proxy to LM Studio on the host. We rewrite the path because handle path strips the prefix ARS, but LM Studio expects v1. So we use handle or re-add it. And better approach, use handle v1 to keep the path intact. Correction on API block, logic, handle, v1, basic auth, API user, to a $14, XTNXLI W6V ULHR5NFOFU02GTNMPKT 5QR7HX4 IJWJPDHJVG reverse proxy, localhost 1234, essential for some API clients to respect the proxy header up, host, upstream host port, Postgres 2, chat interface block, default fallback, handle, the Docker proxy to Docker container, reverse proxy, localhost 3000, logging for observability log, output file, Java, log Caddy access, log, understanding the logic, handle, jut v1 versus handle. Caddy evaluates specific matches first. If the path matches judge v1, it enters the API block. This block enforces basic auth. 23. If authentication passes, It forwards to port 1234, LM Studio. Security implication. This effectively adds a password to your LM Studio API. Without this, anyone who guessed your URL could use your GPU to generate text, potentially incurring costs or blocking your usage. Socket access. For Caddy to get the certs from Tailscale, the Caddy user needs permission to talk to the Tailscale socket. Bash sudo usermod ag tailscale caddy yar. Or modify system service to give access. If this is difficult, Caddy can also just function as a standard HTTPS server if Tailscale funnel is terminating TLS. However, for end-to-end encryption and proper certificate handling, letting Caddy manage the cert via the socket is best. For applying changes, bash sudo systemctl reload caddy 6. End-to-end integration and testing. We now have the complete pipeline. Internet. Tailscale funnel. Caddy. Auth root. 6. 1. Verifying the chat interface. Disconnect your testing device, laptop phone, from the home Wi-Fi. Connect via a different network, e.g. 5G hotspot. 2. Open a browser and navigate to HTTPS, its machine name, tailnet name, tsnet. 3. Checkpoint. You should see the Open Web UI login page. 4. Login. Select the model, local LLM, from the drop-down. 5. Send a message. What is the capital of France? 6. Success. The system should respond. Check Docker logs Open Web UI to see the request hit the container, and journal CLE ULM Studio to see the inference happening on the GPU. 6. 2. Verifying the secure API to test the API endpoint, we use curl. This simulates an external app, like a VS Code extension or a custom Python script, connecting to your backend. Test 1. Unauthenticated, should fail, bash curl. HTTPS, arch machine name, tailnet name, is net v1 models, expected result, HTTP 2, 401, unauthorized. This confirms Caddy is protecting your API. 23. Test 2. Authenticated, should succeed, bash curl, x, get, HTTPS, jark machine name, tailnet name, tsnet, v1 models, tras, API user, my secret API password, expected result, HTTP 2, 200. OK, an adjacent list of models, including local LLM. Test 3. Chat completion bash curl, x post, HTTPS, yarch machine name, tailnet name, tsnet, v1 chat completions, API user, my secret API password, add, h, content type, application, JSON, arch, d, model, local LLM, messages, role, user, content, hello world, expected result, a JSON response containing the generated text, hello, how can I help you today? 7. Advanced security and maintenance. 1. Securing Open Web UI. While Open Web UI has built-in auth, for enterprise-grade security, consider disabling the native auth and using an SSO provider, or simply relying on Tailscale identity if switching to serve mode. Disable sign-up. Once you have created your admin account, update Docker Compose. YML, YAML. Enable sign-up false redeploy with Docker Compose up, D. This prevents strangers who stumble upon your URL from creating accounts. 187. 2. Rate limiting via Caddy to prevent denial of service, DOS attacks on your GPU. Configure rate limiting in Caddy. Code snippet handle, jar v1. Rate limit, zone API zone. 10 Nabita events, 10 window, 1 av. Rest of config. Note, rate limiting requires the rate limit module for Caddy, which may require a custom build. Alternatively, use fail2ban on the host to monitor Caddy access logs for 401 errors. 7. 3. Auto-updating models. GGUF models are updated frequently. Create a cron job or a simple script to update your model. Bash, bin, bash nas, update model. Systemctl, stop LM Studio LMs get, llama 3, 8b instruct, for systemctl, start LM Studio 8. Troubleshooting, guide 8. 1 Docker container cannot connect to host. Symptom, Open Web UI shows connection error or offline. Diagnosis, the container cannot resolve host. Docker, Internal. Fix. Check Docker Compose. YML. Ensure extra hosts is present. Verify the gateway IP by running Docker Network, inspect bridge, and ensuring it matches the gateway. Default 172, 17, 0, 1, 168, 2, tailscale funnel not working. Symptom, public URL times out. Diagnosis, relay servers are blocked or ACLs restrict funnel. Fix, 1. Run tailscale funnel status to check if it's active. 2. Check tailscale admin console. Access controls. Ensure your user is allowed to use funnel. 3. Restart tailscale, sudo systemctl, restart tailscaled. 8. 3 Caddy 502, bad gateway symptom. Caddy returns 502 when accessing the site. Diagnosis, the upstream service, LM Studio or Docker, is down. Fix 1. Check if LM Studio is running. Systemctl status, LM Studio. 2. Check if Docker is running, Docker PS. 3. Verify ports, netstat, TULM. Ensure ports 1234 and 3000 are listening on 127. 0, 0, 1, or 1. 8. 4 GPU not used. Symptom, slow generation speed, 5 TOC S. Diagnosis, LM Studio is running on CPU. Fix, 1. Check NVIDIA SMI to see if LMS process is using VRAM. 2. Check journal CTL, ULM Studio for logs indicating CUDA not found or offloading 0 layers. 3. Ensure the LMS load command in the system service includes GPU max. 9. Conclusion. This architecture represents a mature, sovereign alternative to cloud AI APIs. By leveraging Tailscale Funnel, we have eliminated the most dangerous aspect of self-hosting, opening firewall ports, while maintaining global accessibility. Caddy provides the necessary security layer, wrapping a raw internal API in HTTPS and basic authentication. Docker and LM Studio decouple the application logic from the inference runtime, allowing for independent scaling and updates. The result is a robust, personal AI cloud that is secure by design, privacy-preserving by default, and capable of delivering commercial-grade LLM experiences on your own terms.